All right. Oh, this appears to be on. Hello, everyone. I'm Sev. We're going to get started here. Just going to set myself a little timer for a reminder. So I heard some Docker murmurings out there. Is everybody kind of set up to some degree that they are pleased with? Okay. I thought it would be a good idea to do that you wouldn't have to install everything, but it seems like maybe for some people it's been a little bit of a problem. So apologies. I'm going to go over some ways that you can participate, which include everything from just reading the slides to being fully interactive here. So welcome to the Fellowship of the Data. Thank you for coming and attending. I'm Sev Leonard, Gizmo on the Twitters. And so this is kind of the ways to play. Oh, I have it over here too. So there's a PowerPoint presentation that you can view in a web browser at this tiny URL. There is also a PDF version of it on the GitHub repo in the latest update. So you can follow along there. You can also bring up the notebooks in GitHub itself. So if you just wanted to read through the notebooks, you could do that. So the other possibilities here are to run the tutorial locally in Jupyter. If you have that set up on your laptop and you have the required libs. Some of these details I'll get into as we get more into the presentation. And then you could run the Docker tutorial container by itself, or you could run them both. I'm going to go through some slides that are just kind of an overview, and if you find, like, before we get into the labs that you'd like some additional help getting set up, like, I'll stop and we can take a few minutes to try and get people where they'd like to be for the tutorial. So that's my reminder. So we have like a big break, I think, at about 90 minutes, that there's going to be a snack. I find that I can't listen to information for more than about 45 minutes, so I'm probably going to give us a break every 45 minutes or so. That's why I just set my timer. So hello, I am Sev. A little bit about myself. My pronoun is he. So if you're talking to someone later on, you're like, I went to Sev's tutorial. He is from Portland, is how you would use that. I've been here in Portland for 11 years. I came out here to work at Intel on the first generation of the Core i7 microprocessors called Nehalem. So I have a formal background in hardware. Got kind of sick of that after about 6 years and moved over to doing software development on the application side, just kind of skipped all the way up the stack to UIs and so forth. This is my first PyCon. I've been programming in Python for about 2 to 3 years, and I was really delighted to stumble upon Python when I'd been programming in C# for a long time. So I really enjoy the language very much. I have now achieved a long-term goal of quitting my corporate job, at least temporarily, and I do software and quote-unquote data science consulting. I like mangoes, outside, and cats. So outside, obviously. I'm doing a tutorial about camping for a website I built, and it's Memorial Day weekend, which is the first unofficial camping weekend of the summer, and we are here in the Pacific Northwest, which is beautiful, in a windowless room. But it's okay, because I'm going to show you how you can build a data pipeline of your own to figure out where you can go camping, with the caveat that that would be within the United States. So that's just a little bit about me. Here's just some more class info. Probably the primary thing here is just the GitHub repo, where you can get all the information that we're going to be talking about and doing. So about the tutorial, so this is based on data gathering and organization techniques I used for this site, Camp Near Me, that I built over the, last summer or so. I pulled in data from a number of different data sources that we are going to be working with in the tutorial. So here's the topics that we're going to cover. Mostly this is going to be lab-based. I'm doing a little bit of talking up front, but then we're really going to be mostly in the notebook. I'm going to be covering the technical details of some data gathering techniques like accessing APIs, web scraping, and navigating forms. And then I'm going to get into some object-oriented design topics where we're going to try and use object-oriented design to improve upon the processes of gathering and organizing data from the web, including uniform interface design, extending classes instead of changing your code, encapsulating methods and data. So here's our agenda. Basically, I'm going to talk for a little bit, give you an overview of what we're going to be doing, and then it's all labs where we're basically going to be in the format of stepping through how do you get the data from this interface, and then how do we encapsulate it into object-oriented design patterns, which will culminate in the one pipeline to rule all of the camping things, we hope. Okay, so this is a journey. I know like doing object-oriented programming, for me, sometimes I get kind of frustrated with the tedium up front, and there's really a bigger picture of doing design. So you may, in the first couple labs, be wondering why we're doing all of this wrapping of things, but hopefully it will become more clear as we kind of go through the journey here. And then kind of a bit about the data sources that we'll be using. So the API will be querying, not actually querying because all of this is canned to make sure that we didn't run into any network problems or anything, but the interface that I created a mock from is called the Recreation Information Database. It is a project of the federal government that uses Forest Service data, BLM data, et cetera, to present a very nice, clean API interface for getting information about all kinds of activities that you can do related to those agencies. And then for the web scraping, we're going to be scraping these super like 90s style Forest Service websites. And I'm really glad they haven't updated them because they all have this very nice uniform tabular format, which is going to make it really nice and easy for us to scrape. And then the last thing that we're going to be querying is a form, recreation.gov. This is also going to be a mock in the tutorial, but we're going to go in here and say, okay, we want to find a campsite for these arrival dates at this campground, so what are our options? And first, I just wanted to kind of give, I feel like I would be bad to give a data talk and not talk about tidy data. These are from Hadley Wickham's paper, of course, and the principles of variables are columns, observations are rows, and each table is an observational unit. And so how we think about that with the campground data is an observation is going to be a campground. The variables are going to be campground information. So like the lat long where the campground is there water available? What is the URL for that campground? And then the tables or the observational units are going to be based on the different data sources. So there will be one table for each different data source that we're looking at. Okay, so I'm just going to go over some web data best practices. Get it? It's web data. Anyway, web data is ephemeral, so it's not static. If you've worked with web data, whether it's scraping a web page or interacting with an API, you know that access to that API is not guaranteed tomorrow. That web page's format is going to change whenever, and even like if you have permission to access data, that permission can be taken away at any time. An interesting example of this would be Wolfram Alpha used to have a very interesting app on their web page where you could go in and give it your Facebook login, and it would show you your entire graph network. When Facebook changed app permissions such that every single person would have had to authorize that app to look at that graph, then they were no longer able to authorize the service. So that's something to keep in mind with web data, that it can change out from underneath you. Because most of the time I'm going to assume you're not in charge of those resources that you're scraping or querying. Another one is probably an eye chart on here, but maybe you can see it better on your laptops. So just because you can get at the data, so we have Gollum down here who's got the ring. This is a capture of the LinkedIn terms of use for their API. I was working with a client that wanted me to try and augment a predictive analytics algorithm for targeting products with social media information. They're like, well, we have all these LinkedIn handles. Can you do that? And it's like, well, no, if you look at the terms of use, you can certainly sign up for an API key and get that data, but they're very specific about like you must be developing an application that is using to help LinkedIn members, and your application does not rely on API access as a fundamental aspect of its business. So right there it says you can get this information, but it's really not able to be used in the fashion that my client was requesting. So just because you can get at it doesn't mean you can use it. This is, perhaps people have heard of this, OkCupid collects a lot of data on its users, and when you sign up for the platform, it does tell you, like, hey, we're going to be looking at your data and running analysis on this. However, there's a group of researchers that went out and scraped OkCupid and then made all of this data publicly available, which was a pretty big snafu in terms of like personal privacy. So beware that just because you can get at data doesn't mean that it's good to use it or that you are legally able to use it. So yeah, don't be like that. Terms of use, so attribute properly. The Oregon State Parks Department has a very nice API, and they say, look, if you're going to use our API, this is the terms of use. Also, please give us some sort of citation if you're going to be using it. So that's something to keep in mind when you're working with web data. And you definitely don't want to get this none shall pass issue here, where if you abuse accessing your APIs or you're scraping a web page like a lot, you're going to end up possibly getting blacklisted or having your API credentials revoked. So be aware of that. So kind of a summary of what we just talked about. Web data is highly dynamic from the structure of the information you're getting to your ability to get it. It may not be there tomorrow. So if you are able to store it, I find it's a good idea for me, like when I grab data from the web that I'm going to be using, if I'm allowed to store it based on the terms of use, I do so. And you do have a potential to lose access to that data, either for being blocked or just because it is not going to be there or the company has decided to not make that platform available anymore. So I'm going to touch on some object-oriented design principles. This is kind of an intermediate targeted tutorial, so I wanted to just pass over this a bit. So we're going to be doing class-based design, which this little code snippet over here shows we're using classes to organize our code. We're going to be following some of the solid acronym object-oriented design principles, which you can read more about at this link down here. But basically what the few things that we're going to be looking at in particular is creating classes that do one job. If you have to change something that's going on in your code to do extension to existing classes instead of modifying your code so you can leave it alone, and then trying to make your class dependencies be on abstract entities and not concrete. And I want to point out here that there are some caveats, of course, to all this. Abstract-based classes are not Pythonic. They're not something that you need in Python. If you're not interested in, or you don't know what I'm saying, it's okay, don't worry about it. This is mostly for people that are familiar with class-based design. For me to say, I know I'm breaking some rules here, so please give me some artistic liberty in working through the content. I'm sure you have opinions about how I should have done this or could have done this, but we have a lot of material to get through, and I'd like to focus on moving forward, and we can have those conversations later. So how can object-oriented design help specifically with web data based on what we've just talked about? So maybe we can encapsulate properties that are likely to change, such as API endpoints, parameters, that sort of thing, building on abstractions, so giving a consistent interface for data objects regardless of where they're coming from. And we'll see this in detail. This is just kind of an overview. It'll probably be more obvious as we get into the labs. And to extend existing classes to accommodate changes, such as creating web scraper objects that can be extended. And this is something that I actually had to do with camp near me. I had a web scraper set up to get reservation information, and then one day it just stopped working. I was like, oh crap, the whole thing has changed. Well, in fact, just the name of the form that I was connecting to changed, so I was able to extend the class that I made and just have my connection method be different, so I didn't have to touch any of that code. I just made a couple new lines in a method that already existed in an extended object. So that can be a really nice thing if you are able to do that. And then, of course, with object-oriented design versus kind of spaghetti code, which is definitely like how I start out is the spaghetti code and then like try and refactor into something that is good, is that you end up with creating maintainable structures that you can test easily. And we had a speaker at our local PyCon or Python user group this week that was talking about writing code, and he said, you're not good at writing code if it just works. Writing good code means writing code that you can test and you have tested, so that's important. We're not going to be testing any of this code, by the way, so maybe it's bad. It probably isn't. Okay, so we'll dive into the RIDB API, which I've already kind of talked through. I got a screenshot, which if you can see locally, probably better, to just show you, or you can even pull it up on the link here. RIDB is really well put together. It's a very nicely documented API. As you can see, there's a variety of endpoints that you can use. You can get camping, hiking information. You can find out about specific campsites. You can even find out where you can go into a park. So it's a very rich API, well documented. It has a very responsive team on GitHub that it will respond to issues. So this is kind of like the Cadillac. I compare it to like the elves because they're super sleek and they're really, I don't know, efficient and elegant, like this API. So some notes about the RIDB data. So this only has campgrounds that can be reserved. So anything that's a first come, first served campground will be absent from this data set. There are no reservation URLs, despite it being like, hey, you know, here's a URL, you'll see that that field is blank, in fact. And the lat longs are not guaranteed to be accurate, which is extremely interesting if you're telling people, hey, you can go camp here. And I was looking at an example last night of one of the campgrounds locally, and the lat longs have it in the middle of a lake, which it definitely is not. So, okay, cool. Now we're going to go do lab things. So I'm going to, let me see, can I tab out of this and tab over to? Okay, so now I am done talking, hopefully for a while. Oh. How are people doing on your setup? Kind of, if you need some help, can you raise a hand and I can come? Okay, do I have a helper in the room? Did I get any tutorial helpers? No? Okay. Those of you who need help, is anybody on Windows or Mac OS? Of the people who need help? Okay. This is a lot of people I was expecting to have a helper. Okay. I'm going to take about, let me try and take about 10 minutes or so, and I'll walk around the room and see what I can do about helping you all with your setup, and then we can dive in. Let's see, I'll turn this off. Is this on? Oh, it is. Okay, we're going to proceed with getting into the lab material so we get through that. So if you go over to where you are running the Jupyter in your browser and open up Lab 1, RIDB API. Okay, so basically this is all set up, so we're just going to kind of walk through and execute the commands, and hopefully things will all work. If not, I'll cry. Okay, so the RIDB API, we're starting off here in the Shire. We're going to start by loading up the libraries we're going to need, and then here is our endpoint URL for getting the facilities data from RIDB. And then I'm going to set up some parameters. So if you're familiar with working with APIs, you have to tell it what you want. So this is what we're telling it we want. We want activity ID 9, which I know is camping. What? Can I make it bigger? That I don't know. Let's see if I can make this bigger. Hamburger. Thank you. Okay, and maybe I can make this. Oh. Is that legible? Can you see? Yes? Okay, cool. Thank you. So we're going to set up our lat and long. This is somewhere near Mount Hood. So Mount Hood's a pretty cool place to go camping. And we're going to look for campsites within about 15 miles of there. And then we're going to, this is a JSON response that we get back from the API, so we will be loading it into our, let's see here. That does not look like what I expected it to. So this would be if we were using the live version of the API here. So I'm going to try and connect and see what happens. It says no. So the live connection is not going to let me go out. Okay, that's fine, because we're using the canned version. So this is the canned version, where we're using a local URL that's running on the LAMP instance, the LAMP container. So we got our camping, and so here is our camping data frame that we got back that's going to show us there's going to be 16 entries in here, and just kind of like to go through and look at the data that we're getting back. So we get a description of what the facility is, instructions on how to get there. You'll notice there's a lot of empty columns here for no email or a map. We have lat and long, some IDs. Some places have phone numbers, and then lets us know when the data was last updated, which is really nice. In Oregon and Washington, our data gets updated pretty regularly, which is great. And so we'll just kind of look through, do some data exploration on this. So I want to get an idea of when has this stuff been updated. It looks like most is pretty recent. I mean, some of it looks like it hasn't been updated since last year. It's more of an FYI at this point. These are the different legacy IDs here. So we're going to go and clean up the data. So first, when I'm working with data, I like to constantly be checking on the shape of the data, because that's kind of a smell if the shape changes in a way you don't expect, that something untoward happened, perhaps. So this is telling us that we have 17 campsites in our little data frame here. So another thing I'm going to do is a lot of the handling of empty strings and nuns and et cetera can get kind of hairy when you're working between text data from an API, putting stuff into a database, pulling things out of CSVs. So I'm going to straight away just replace any empty strings with nans. And then this is just a note for the live data, because the SQL thing we're using does not support GeoJSON. So we don't have to do that because we're not using the live data. So then we're going to say, we're going to look and see if we have any nulls here for facility latitude and longitude, because this, what we're going to be doing at the end is putting this on a map. And if we don't have a lat long, then we're not going to be able to put this on a map. So we're going to take that out of our data set. So I'm going to drop that one campground, and then in fact it has been dropped. And then we're going to come back here and check our shape again. So now we have 16 instead of 17 because we've dropped the one that didn't have any information. And then let's say I'm going to write it to a CSV, and then I'm going to read it back out just to make sure that everything looks right. In fact, I do have the same data. I didn't, index equals false is pretty important if you don't want to end up with a million different indexes, because it'll write an extra index out to the CSV if you don't. It has our nans as we had replaced with. And then here, let's see, I'm going to create my database connection. So just to go through a few different storage methods here. And so I'm going to, hopefully that'll work. Yes, okay. So I just took my data frame and stuffed it in my database. And then I'm going to get it back out and be like, is it actually there? Yes, and the nans are right, and the indexes are right. Very cool. I guess I don't know that we necessarily need to do anything. Yep, just kind of double checking some of these other things. So we do have is null, and it's not like an empty string. So this is just an overview of getting information out of the API, doing our extraction, cleaning, and storage, which is kind of like the typical data ETL process. So now that we've gone through how to work with that, the RIDB API specifically, I'm going to leave the page, yes. We're going to now look at how to do this in a object-oriented way. So I'm going to start with looking at the storage piece. So that's one thing that is pretty obvious how to encapsulate, maybe not obvious, but it's one of the ways that I prefer to write my code is to encapsulate the storage options, because you may be asked to connect to a different database, the things that you're querying from may move, so it's good to have options when you're working with storage. So let's see, I'm going to take a look at this. So this is an abstract base class, which again is not a Python thing, it's just for teaching purposes that I'm showing you this. So we have this class storage, and what were we doing with the data? We were taking our data frame of information we got from RIDB, and we were putting it into a database, or we're going to get it back out to do analysis on it. So these are just going to be kind of like a dumb interface that you say, look, just put the data someplace or get it back for me. I don't care what you're doing or how you're doing it. And this is going to serve to give us a common interface to design to when we make storage objects, which means that you will be able to pass any type of storage object to something that is expecting these get put methods. So I have a method here, or a class here that I've created called CSV storage, which, as you might guess, is for storing to CSVs. So in here, my get and put methods are specifically saying, okay, for the name of the element, so if I go through here in my superclass here, I have a name that I'm giving the object. And then I'm going to pass that name in this implementation of the storage class as CVS storage. I'm just going to give it the name CVS storage. And then I'm going to say, okay, so I'm going to have a put and a get routine, bless you. And I'm going to say, okay, send me a data frame, give me the name of the thing that I'm putting, and then I'm going to just do the put here in for CSV and the get similarly. And another class that I'm creating based on the storage class, so with the same interface, is for MySQL. So I've basically taken the methods that we just kind of walked through step by step, and I'm encapsulating these into these objects. So again, this is putting the data frame you send in, it's going to put it in. You'll notice that this is, one, writing all of the data, and two, replacing the existing data. So that's something you would want to know if you were instantiating these classes, that you're going to be destroying data when you put, which is what I just mentioned here. Excellent. So let's start using our objects and see how this works. So I'm going to create a new MySQL storage object. And we just put in test. So let's see if I can get it back. So in fact, I was able to get back my test data object that I stored in lab 1. And then if we do the same thing here with our storage CSV, so we've created a new object that stores CSV. And then I'm going to say I've already saved a CSV test, so I should be able to get it back. And yes, in fact, using the object, I am. So that was an object to encapsulate the storage. And there's going to be, when it comes to explaining object-oriented concepts, I find pictures are better. There's going to be a picture after this. So yeah, I don't follow the code well when it comes to stuff like this. So there will be pictures. So we're going to do the same method to the data extraction process. So remember, we connected to the RIDB, we got the information out of it, and we did some cleaning. So this is going to be kind of our data extraction and cleaning object. So if I look at, I now have another abstract subclass, data, which has an extract method This is, if you're unfamiliar with classes in Python, this is the constructor is in it. And so it's giving itself a name. It also has its own data. So this has a data object within it in addition to the extract method. So recall from lab 1, this is what we were putting into our, to the RIDB to get out the information we need. So one of the things that I'm going to do I'm going to make this RIDB data object that is based on the data superclass we just talked about. I'm going to encapsulate whatever I can here. So this activity dict, this means that I'm going to be able to keep, let's say the activity numbers change, something goes on the API. All of that is going to be encapsulated in this object itself. So anything instantiating it doesn't have to worry about these numbers. It can just say camping. And I'll show you that when I actually do the instantiation. I've also encapsulated in here the RIDB endpoint itself. You could also put that in a config file. And then the initialization method is just pulling in what do you want to name the subsequent storage information. The activity, so this would be camping, the parameters, so we'll have a stripped down list of parameters, which I'll show you in a minute. And this also is going to take in the storage object that we just made. And this is, again, this is kind of like not really a Python thing, but we're going to be able to, because we're basing all of our storage objects on the same interface, we're going to be able to pass in anything that implements that interface, whether it's CSV or MySQL or something else. And hopefully this will all become more obvious in a minute. And then there's some various cleaning, so we were going to do the replace nans, look and drop anything that doesn't have lat long, clean up if we're using live data, we're going to drop geocoordinates. And then this is actually doing the extraction here, where we're going to connect to the mock, and we're going to get that information from there. And so we're going to, let me see this. Yes. So we're going to have in here these put and get methods where we're going to be referencing the storage object that we put in, because that is the class that's going to be handling all of that stuff, not this actual class itself. So then I have another one that I made. This is a further level of, so we're going to extend the RIDB data class with something called RIDB data live. So basically the only difference here is it's going to use, let me see, I think that changed. Yes. So it's going to use the endpoint that we defined up here, because of course, so we have the endpoint here, but what we're actually querying here is the mock, if you notice here. So I still have the information of what endpoint to use. I'm just not using it in that implementation of the class, but I am going to use it in this extension of the class, so that if you wanted to use the live data, you can just use this alternate, the RIDB data live that has a different extraction class or method on it. Okay, that was a lot of talking. I think it'll be more clear if I give an example. So I have my destination parameters, so I still need to tell it where I want to go and how far around that place that I want to look, so 15 miles. And then when I create the data object, I'm going to call it RIDB camping. The activity I'm going to be going on is camping, with the destination parameters and the SQL storage object that we already created. And then there's this live one. I'll comment that out. But that's if all of this code will work on the live web pages and databases. You just need to, like if you have a RIDB API key, you could use this RIDB data, this RIDB camping live script to actually get at it. It should be exactly the same. So we don't have anything in our data frame yet because we haven't extracted. So, oh yeah, I did define this dude. We're not doing this. Typo. Okay. So we just did RIDB camping.extract. So this is going to extract from us the same data from the RIDB mock that's hosted on the LAMP container. So you can see that we have the same set of data. So we keep looking at the same set of data. I know it's kind of boring, but just to motivate with these same examples for consistency. And that one we didn't run. So there's other things that you can do. So we also had hiking in our list of parameters to get. So if you were on a live, I'm being reminded we should quit soon. If you're using the live database, you could go out and get hiking information as well using the same object. And so we have our camping. We're going to put that, and that will put it in the database. And that is pretty much the code portion of this. So if I come back to where we're at, so we did lab 1 and 2. So to summarize what we were just talking about, so what I'm showing here is kind of your typical data flow where you're going to connect to the source, extract the data, clean and format, and store. And what we've done is kind of wrap these in different classes. So we have a data class, a data object, that's wrapping the connection to the cleaning piece. We have a separate storage object that is going to handle the storage piece, and these are both those abstract classes. And then we have the RIDB data object that is encapsulating both of these. So you can instantiate that object, which is going to give you all of the source to clean and format pieces and the storage. And then this would be the diagram of kind of what our data looks like. So these dotted lines indicate like an abstract, an interface idea, so you can think of it maybe as more of a noded interface than an abstract class. But so we have a storage interface, and then we have implementations of it as SQL storage and CVS storage objects. And then similarly with the data interface, we have RIDB data, and then we've extended the RIDB data class to RIDB data live if you want to use something other than the mock. Okay. So my little timer went off that said it's been about 45 minutes. So I think it'd be a good time to just take a break. We also just covered kind of like a lot of stuff. So why don't people take, I don't know, 5 minutes or so, get up, take a walk, or if you have any questions. Yeah, I guess I should tell you what time we should come back. It's 12:12 on my clock, so like 12:17, 12:20, or 2:20, sorry. going to put this mic back on. Okay. All right. Great. Let me go back to what's up there. Okay. So we've gotten camping data out of the RIDB. We've set up objects that are going to let us store information. We've set up objects that are going to let us get information from it, the RIDB interface. So now we're going to move on to scraping websites. And when I think about scraping websites, it's kind of like Gimli. He's very effective, but kind of in this coarse way. So our axes are selenium and beautiful soup that we will be using here. The USFS data, some information about it. There's no API. The links are discovered through scraping. I have like a meta scraper that scrapes the stuff that I'm going to scrape, so we're not going to talk about that here. I'm just going to give us the links. Fortunately, the pages are fairly uniform, and so this was the, we'll probably come back and reference this. So I've kind of outlined in orange kind of some of the areas that we're interested in scraping. So we'd like to know if the campground is open or closed, probably important information. What kind of conditions are, if it's, you know, if there's a tree down or something, we'd want to know that. People seem to be really interested in knowing about what the toilet and water situation is when they're camping. That seems reasonable, so we can get that kind of information also. And so from here, we're going to go back to the Jupyter Notebooks, and I'm going to walk us through the process of doing the web scrape. I figured out I wasn't connected to the wireless. That's why RIDB Live didn't work. So no wireless connection, no live scraping, which is good to know that I had a good reason for making canned data. So we are heading into the forest, the national forest. And so the scraping techniques that I'm showing you here can be used on pages such as this one, which, do I have internet? Yeah, not really. But anyway, if you want to use this on other websites, that's the kind that you could use them on. So I'm going to be importing the libraries here that I will use. Beautiful Soup is a really awesome library. Oh, this came up, yeah. So should look, nope, never mind. So, like I said, we're just going to somehow magically get these site URLs. It's a gift from the elves. So we're going to read up the URLs available. And so they are organized by the facility name and what the local cached URL is. So these are, we have 8 campsites that we have a matching Forest Service URL for. So let's see, let's just look at one at a time here. So what I'm going to do is I'm going to connect over to the LAMP container. I'm going to use this first entry here, and we're going to look at, we're going to get the URL, and then we're going to read it into Beautiful Soup, which is a library for web scraping. It's going to give us this soup object that we will navigate through. So it looks like that worked. If you are not able to get connected to the LAMP container, you can also read it locally from the web files directory. So now we're going to try extracting the area status information. So I think here, I'm going to go over to the web files, and I'm going to open up, let's say, Lost Lake. So these are some things that I do when I'm going to be scraping a web page. So I'm going to kind of talk through a little bit of, we want this area status situation, which if we come back over to here, we have this area status, uppercase A, uppercase S. So let's look and see if we can find that. So, hello? Okay, cool. So there is area status. Another thing I like to do, so we found it, area status. There's a strong tag on either side of it, and then it has the status as open. So one of the ways that you can scrape information is by looking for either unique names or IDs, or looking for specific tags and text that's associated. So next thing I'm going to do is look and see, does area status occur again? Doesn't seem so. I think I have to, there we go. Okay, so I have area status, and that seems to be it on line 3774. That's the other interesting thing about these web pages. They're enormous. So what I'm going to do is take this information that I have. I know it's between a strong tag. I know it's going to say area status. And bring that back over to Beautiful Soup. And I'm going to say, I'm going to look for all tags in my soup that are strong. And then I'm going to iterate through each tag, and I'm going to look for area status in the string that's in that strong tag. And then I'm going to get the status from this text here open. Well, that's what I'm going to be scraping with this. So we'll get this, and then we'll say we've scraped this into status, and it didn't print an exception, so it must have something in this little status variable, and in fact, it's telling us it's open. So similarly, we're going to look back at the latitude, longitude here. So that's in this little location box down here. So if I go back here, oh, I know it's there. Clear this. Okay. So I found that latitude, longitude, and elevation box down here. And I'm going to look around and see, okay, it's obviously in some sort of a div of divs situation. So I have a div that has latitude here, and then in the next div, there's the value. And then I have this pattern again. So there's a div with longitude and the div with the value. Same for elevation. So when I look at trying to scrape that with Beautiful Soup, I'm going to say find all the divs that have the text. Let's say we're just looking for latitude right now for latitude. And then Beautiful Soup has this really interesting way of you can navigate the hierarchy that you're working in. So I'm going to say when I find that row, I'm going to go to the next sibling, which means, so the sibling of this div is another, wrong page. So I'm going to go into here, into this div, and I'm going to extract the information from there. So that in that div, I'm going to get the latitude. So try this, and then it's retrieving the latitude for us. And so as I pointed out, we can put this just in one get location function because it's all of these lat, long, and elevation are using this same pattern. So I'm going to make this function just called get location, and I'm going to pass in the soup, and I'm going to pass in the search text that's going to be in this find all statement. Okay, and then I can use the same thing and get lat, long, and elevation. And then if I print that out, I've retrieved the lat, long, and elevation. And then finally, we're going to look at the campground info. So I'll just kind of get to the punchline on that one. Table color. Okay, so let's see, table color. There's this one, there are several of them. So this is a case, what was that? Reservations, let me look for that. Okay, reservations, fees, camping. I believe that is the right area, current conditions. Look for that. Okay. So here we are at a glance. We've got our current condition. So if I go back to here, what I'm looking for is this at a glance table that has all of this information in it. So I'm going to look for current conditions, water, restroom, any of the other entities here I want to get. So I found that this is in div class table color, but there's actually many of this div named in this HTML file. So I'm going to get all of the table color divs. But what I noticed is when I went through and was looking through this HTML, there are many table colors, but always the first table color div is this at a glance. So positionally, I can refer to this table color div and know that I'm getting this information. So that's exactly what I'm doing here, is I'm saying get all of the tables that are of class table color. I'm going to take the first table in that div. And then the other thing I'm noticing here is how do I get the current condition? So I have, this isn't a table. The table row header is going to say current conditions or reservation, the entity that I'm after. And then the table data right after that is going to have that value. So here I am extracting out. So I'm looking for the table header text is reservations. Then my reservations is going to come from that, and so forth. So we'll do get the tables. And then I'm going to try getting all of this information, and I'm going to save it into this data frame down here, df-info. Okay, so then if I look at df-info, what I've got is I've scraped the current conditions, the facility name, it's open in April, I know what the reservations are, and most importantly, I know that there is a restroom, and there's 18 restrooms, actually, and water. So that's how you would extract information from these Forest Service web pages. So again, now that I've showed you how to extract the data, I'm going to show you how I'm going to encapsulate it so you can put it into an object that does this for you. Okay. Okay. So I'm going to introduce a web scraper object. So we have storage objects, we have data objects. I'm going to introduce a object that is going to be used for us to build on for web scraping. So I'm going to import my classes, and then I'm going to import, these are the web scrapers. And then I'm going to come over and take a look at, so all of the classes information is in this folder called classes. So if I come here and I look for scraper.py, so this is again like my abstract, my interface for a web scraper. So I'm going to have a function basically that says scrape. There's some ways that I extended this that we're going to look at that makes it a little bit more dynamic as we're implementing the different web scrapers. So for this one, I have, let's see, UFSFS web scraper. So this is the implementation. It's just passing all the initialization stuff straight through this to the superclass. I don't have any different initialization things. And then I have down here my scrape routine my scrape method that I've implemented. And then all of this stuff up here is just for encapsulating the methods that we just talked about. So for instance, I have a, let's see, so we have the get location. So we walked through that method previously where you're going to get lat long and elevation through this method. And then I just have the get area status and get campground info out in separate methods. And also I have this get soup method that has been pulled out specifically here. And I'll show you why in a minute. But then this goes through, it scrapes the information, and then it's returning a data frame with all the scraped information in it. So if I come back to the lab, so that's the USFS web scrapers what I just walked through, and that's what I just imported. So again, I'm going to go and get our list of sites. I'm going to create, I should talk about the scraper data stuff too. So I also have a class called scraper data, which again is implementing the data interface here, or data abstract class. And I have extract, put, get methods. So same kind of interface. The difference here is I'm passing in a scraper. So I can send all of the scrape routines. The extraction basically goes down to this scraper class. Okay. So I have the web scraper. And then I'm going to initialize my scraper data class. I'm going to call it USFS. I'm going to pass in these URLs, which is what I'm going to be scraping. I'm going to tell it the storage object that I want to use, and I'm going to tell it the web scraper that I want to use. So now if that's not working, I made this new and improved web scraper local by extending the web scraper class because I thought, well, if the LAMP instance is not running for people, then I'll just create a different implementation of get soup where you can read locally. So that's how you can, again, use object-oriented design to extend and give yourself new functionality without writing a lot of code and without touching the code that you have already tested, debugged, etc. So we can try that out too. That should also work. Great. So going to do the extract function. So remember, this is our data interface, so we have extract, put, and get. And that is going to get, scrape all of the information for these websites. So some of them are open, some of them are closed, some of them have no information. Let's see, many of them have toilets, it seems, which is good. I thought one of them actually had a flush toilet. Yes, Eagle Creek has flush toilets. So that's getting all of your information from those web pages. So just talked about how we're going to get information out of USFS website pages, and then how we're wrapping those in objects. I think I might have a slide or two on that. Yes. So this is kind of the saving tutorials with object-oriented design. I call this because I have web scraper local, so if you, for some reason, couldn't get at the other stuff, it's here. So this is the objects we've already talked about. So we have this, we now have three kind of abstract interfaces. We have storage, data, we have scraper. We've already implemented the storage classes over here, MySQL and CSV, and then all this stuff in orange is new. So we have scraper data, which is built on these abstractions of storage, data, and scraper. So again, you can pass in, for this, either of these classes would work. Any kind of data class could work for this. Any kind of scraper, whether you're using this scraper or this scraper, would work with this object. Okay. Oh no, didn't mean to do that. Okay, so now we've kind of built up data from RIDB, data from these web pages, and now we're going to add this like final piece, which is getting reservation information from these from the recreation.gov interface. So this is, most of these things are maintained by the same agencies, which is interesting that it doesn't all have consistent data. But this is the government's website where you can go and find sites to reserve. So similar to the interface for Reserve America, if you've had the displeasure of using that website. What we're going to do is we're going to fill out these availability things with arrival date and departure date, and then submit the form. And then we're going to go on to labs 5 and 6 here. Let's see. Okay, so now we're going to be relying on a more advanced form of magic called Selenium to do our web scraping. So I'm going to bring in Selenium. It's a package that people use for UI, web UI testing and also some scraping, and it's going to enable us to robotically maneuver through forms, which is really helpful. So to start up Selenium, Selenium works by having a display. So some things you might run into, that I ran into running Selenium, is it needs to actually be able to see the element that you've loaded up. So you need to start displays. The other thing is, for this tutorial, I've enabled Selenium to run in like a headless mode, so we're not going to have browsers popping up. It's all going to handle it in the background. That's these display. Yes?
How do you deal with dynamic elements when using Selenium? Like, you're scraping from a page that I'm assuming you know the schema.
Yes.
So how do you deal with the dynamic elements?
The dynamic elements, meaning what if they change?
Right.
Can't, I don't know. Like, that's because you're...
Or if the IDs change, like if you're trying to...
If the well...
Yeah, but that's kind of brittle, no?
What is it?
I mean, you could use XPath.
Mm-hmm.
I mean, again, that's dependent on the schema not changing.
Yes. Well, and that's kind of like similar to what we've been talking about, right? Is that if the schema changes, you're kind of busted. So regardless if you're using Selenium or other form scraping, that's going to have kind of the same effect.
To alleviate something like that, does it make sense to possibly take the object that you're scraping off of the web page and dump that directly into like a MySQL column, and then you can export, and then you could pretty much use the database to do all of that manipulation?
if you can get to it, because remember you said what happens if it changes. So if you can get to it, and if you can like generalize the fields in that object that you're looking for, that might be something that would work. Yes?
Yeah, I don't know if there's a way to make it self-healing, but the way that I've approached this is to just to set up tests, honestly, that run regularly and or like me or some, actually like right to let a human know when something has changed that needs to be fixed. That way, like you can't solve for the brittleness as far as I'm aware, but you can at least make sure the time between something becoming broken and anyone finding out is as smooth as possible. So building your own system so that your users aren't building systems.
Yeah, that's a great idea to kind of like, I don't know if you were able to hear them, what they said, but basically make a thing to alert you when it breaks so you know to fix it, which is...
Couldn't you just stop importing data? If you have an automated import, let's say your test breaks, and you just don't...
Oh, sure, yes, yeah, and then you just know that you're serving dirty data until, yeah, that would be a good way to do it so you don't end up borking your database. So, yeah, good question, good discussion. So I'm gonna, Selenium has been a little bit temperamental for me, so hopefully this will go through. Let's see, so we're doing, I'm gonna set up the web browser. I'm gonna tell it what size I want it to be, which really doesn't mean much to us because it's not gonna be visually available. This is our facility URL that we're gonna use for getting the reservations. And I'm gonna try and connect here. Looked like that went well, so basically what's going on is I'm connecting to the facility URL. I'm giving it a timeout to basically say, give it some time to load. So if Selenium, again, if Selenium doesn't see it, it doesn't think it's there. So you sometimes need to give these waits to let it wait for objects to appear on the document schema. So then I'm going to look for these elements. So maybe we should stop and go back and see if there's a data, images, web files. Yes. So reservations.html. So this is my fake web page. This is modeled after the actual form that you would be interacting with on recreation.gov, so it has the same names, that sort of thing. So I know that the form is named, so I'm going to look for this form, and then the inputs have these names respectively, so I'm going to look for those names as well. So that's what I've done here, is I'm looking for those elements. And so what I'm going to say is I want to start camping tomorrow. I'm going to go for 2 days. And then I'm going to generate, the reason I'm doing this is it's a little bit, what you want to go on a start date, how many days you go is kind of a more typical user interface and start and end date. So I just compute the end date here. So I'm going to say, all right, I'm going to go from 6.1 to 6.3. And then I'm going to send over this information over Selenium to the form. And I'm going to find the submit button and click it. Okay. And then what I'm doing here is I'm going to create another soup based on the response that I'm going to get after the submission has occurred. So let's see. I'm looking for the match summary. So match summary is going to be the element on the result of that PHP page call that's going to be showing us where, like how many sites are going to be available. So then I'm going through, find this match summary and get the text. And it's telling me there's 5 sites available at this one campsite that we just walked through. So this is how you would go through form manipulation to get at data that you have to walk through type of a submission process for. And that's how we're getting our availability for our campsites. All right. So then we've walked through kind of how to get the information. So as with the other labs, we're going to walk through how to encapsulate that. So reservation and scraping objects. So similarly, since we already have this scraper object, we can just make another scraper object specifically for reservations. So if I come back here, I'll close these, to my classes. And so I have scraper, web scraper, and where's reservation scraper? Okay. So I'm doing all the imports for Selenium. And then here is my interface. I have my init that's doing the initialization work. And then I have my scrape routine, which is the interface that we expect with a scraper object. So my scrape routine is basically encapsulating all of the routines that we just walked through. And then it's going to, again, consistent with the other scraping objects, it's going to return a data frame of that information. So if we just walk through here, let's see, we're setting it up. We're going to have a separate connect to page because that may change depending on how you're trying to get to a URL. This is covering all of the submit requests, so finding the elements, giving it the information you want. And then this is after you're waiting to get the response, you're going to get the information out of the resulting server response there. So pretty straightforward. So if we go back to the lab, is this the one we're on? Reservation scraping object? I think so. All right, so we're going to load this up. And the elves have gifted us these reservation links kindly. So what have we got here? So we have in our reservation links, we have the facility is identified by latitude, longitude, facility name, and then it gives us our URL. In this case, it's all the same because it's a mock. So I'm going to set up when I want to go camping. So I'm going to tell it I want to go camping the next couple days, and then I'm going to say, oh yes, I'm going to augment this data frame to give it that information. So it knows for each, because the scraper object is operating on each observation, on each row, it's going to need to know start, date, and stay length to be consistent with interfaces. So I basically have this new data frame that has all the information about the campground, the reservation URL, and when we want to go. So then I'm going to go back and create another scraper data object. So again, we can use the same data object. All we're doing is we're passing in a different scraper. So remember before we were using the USFS web scraper to instantiate our scraper data object. Now we can just pass in this reservation scraper in the same constructor to instantiate our reservations data object. So I'm going to create that object. Let's see. I'm going to run the data extract. Please work. Yes. All right. So it has extracted all of the information. And then we're going to get the data that's part of that res data object. And it tells us that these are the sites that are available. Fortunately, there are sites available at all of these campgrounds, which is pretty great. And then we can put the reservation data into the database if you want to store it. So let me go and do a kind of summary here. So to add to our list of objects that we have the storage object, the storage abstraction, the data abstraction, and the scraper abstraction. So we're basically adding a new subclass of scraper, reservation scraper here, which can then be used, as I was showing, in the scraper data object, just like this Forest Service web scraper, because again, they're implementing the same interface. Let's see. So at this point, that's kind of covered all of the data extraction techniques, and we have more time than I anticipated. So does anybody have any questions on what we have covered to this point? Okay, in the back of the room?
Yeah, kind of related to the design. I guess, I don't know if this is like more specific to camping, but is that adding a new column in there?
Mm-hmm.
I know that it's adding a new column of that start date inside your DF. Is that the best way to add a new column in your code? I know sometimes, you specify like you initiate at the very top,
Mm-hmm.
but it's not like bad practice, I guess, to throw at the bottom. I wasn't sure if, for readability, whether it's better to, kind of initialize the whole DF with everything, all the columns.
So do you mean like, I want to make sure I understand what you're asking. So as if the arrival date and stay length should be specified as part of the class, you mean? Or you mean just the order in the Jupyter notebook?
Oh, I mean specifically, if you specify the data frame, if you were to specify the headers of it,
Mm-hmm.
is it better to have start date and stay length empty, but state that those columns will exist later on?
I see what you're saying.
Safe to do assign.
It really depends. So we're interacting with the data frame in this lab as a fully dynamic object. So I think probably the better way to deal with it would be when you're creating the data frame to just create it all at once, so you're not procedurally adding more things into it. So I think from that point of view, yeah, like to kind of revisit what we were looking at here, so maybe if we were to take and come up with this stay length, start date, et cetera, and kind of define that, and then when we create this data frame, kind of create all of it at once, sure. Like that would be a more, probably a more readable way to do that, sure.
Okay.
Yep.
Thank you.
Yes?
Have you had any experience with the Phantom JS headless browser with Selenium instead of Firefox?
Yeah. I hit a couple of Selenium errors going through the tutorial, and I don't think the Phantom JS was one of them. I did have a problem where, like, if we try and rerun this extraction, I think it's going to fail. That I've noticed if I run Selenium. Yeah, so if I run it again, what I notice, unless I restart my kernel, is that I'll get this error. And I know it was leaving behind some like zombie instances of Firefox that I removed, and that doesn't seem to work. So that is more of the error that I've run into than the Phantom JS one.
Phantom JS is a separate browser from Firefox.
Right, but I haven't used Phantom JS.
Okay.
Yeah. Any other questions? Yeah.
At the bottom of this notebook, when you do the put,
Yes.
I'm trying to understand the class structure there.
Okay.
Because the res data is a scraper, right? It's a reservation scraper.
No, the res data, that's a good question. So this thing is falling off my ear. Not made for my ears, I guess. So res data, if we come back up here, so res data is a scraper data type. So if we kind of go back to the classes and look at scraper data, so this interface has an extract, a put, and a get. And as a constructor, you pass in the storage that's going to handle those get and put routines, and you handle the scraper, or you send in the scraper, which is essentially going to handle this extract routine. Does that answer your question?
Yeah, so basically the storage implementation
Mm-hmm.
manages the putting data, it puts the data in MySQL, right?
Yes.
And then I guess I'm just looking for a reservation storage or something like that, or is it just kind of, is that mapped or something in an RM or something like that, or?
When you say reservation storage, like,
So, maybe I misunderstood. So I understand this is putting this reservation data into the MySQL database, right?
yes.
Okay, and then there's a storage class implementation somewhere, I guess.
Yes. So this, up here, we've created the scraper object, and we've created the MySQL storage object. So that's, okay, that's where that's coming from.
Okay, thank you.
Sure. Is there any more? Yeah.
May I just use the Selenium without using beautiful?
Sorry, I couldn't hear you.
May I just use the Selenium only without using beautiful soup?
That's a good question. I don't know. Yes, you're shaking your head. Yes.
Yeah, I use it. Yeah. You're only using Beautiful Soup to parse the results
Mhm.
that Selenium is giving back to you.
Yes.
Selenium itself is enough.
Right,
Yeah, I think Selenium, doesn't it have Beautiful Soup in it or something, or it has a parsing?
Well, maybe it internally uses Beautiful Soup. But
Okay.
I use Selenium without instantiating Beautiful Soup.
Mhm.
You know, a pandas can actually take an HTML page.
That's
and
true.
Split it into
Yes.
tables.
Mhm.
So I use that.
Yep. Many ways to go about the data scraping. Thank you. Let's see. Do you have any more questions? Sure.
I just wondered about the abstract base class and the non-Pythonic nature of it. I mean, it seems a nice, clear way to
Mhm.
establish a template. So what's wrong with it from a Python?
So from what I understand, remember I come from a C# background mostly, so I'm sure somebody might be able to explain this better than me, but I'll get to you in a minute, Max. There is nothing in that class. Python just kind of will allow you to pass classes without checking these kinds of interface rules that kind of different high-level languages like C# will do. So it's just extra code that you have to maintain. It doesn't have to be there. It doesn't really provide any kind of value. Were you wanting to elaborate on that?
So yeah, I was just going to say that with Python, interfaces are useful, but declaring abstract-based classes, you can either make them a class and just say if you didn't implement all the methods, it won't work. Because any failure that happens is runtime failure.
Mm-hmm.
Unless, so there is a Python library called ABC, abstract-based class, which is a meta class-based setup, which will fail on instantiation of a class if all the methods aren't implemented. Otherwise, you are getting otherwise if you just do like an assert or a raise not implemented exception, the behavior is exactly the same as if you didn't have, or almost exactly the same. The exact nature of the exception raise is slightly different than if you hadn't done any method at all. And because they're almost indistinguishable in that respect, there's because you never declare anything, it's not like you need the method headers. It's not like you need the class definitions to be exact, like you do in compiled languages like C#.
Yeah.
So
Have you used ABC?
I have used ABC, yes. I have mixed feelings on ABC. I have mixed feelings on classes in Python in general.
Okay. Thank you. All right. I think there was another question. Maybe. No? No more questions? Okay. Well, I think you're supposed to have a snack in like 4 minutes, meaning you and me. So if you guys want to go, I don't want to start a new second breakfast, 11sies. I don't know what we're calling this, but yeah, you guys can go have a snack, and I'll probably come too. And then when is snack time over? Is it like 20 minutes or? Okay. So I guess guess we'll see you at 3:20-ish. And if anybody still needs help, yeah, please come and I will help you out. Can you hear me? No? Yes? Hold on. Technical difficulties. All right. Yes, good. Okay. So I hope you all had a nice snack. Let's go back to the slides. As it turns out, we're getting through this material really quickly. So I have like 2 more labs left, and that was really it. So I'm going to go through the material I have, and then like if you have any questions or want to go back through things or anything like that, let me know, and I'm happy to stick around and do that. So, all right. So. Is this before it? Yes. So now that we have all of this information, so we have objects to get information from RIDB, from the websites, from recreation.gov, we need to merge all of this information if we're going to look at it in one giant data frame and then display it, do analysis on it, that sort of a thing. So this next lab is going to be walking through how we're going to be doing the merge, and then we're going to also have a merge object that's associated with that. So if we go back over here to the notebooks. All right, merge all the data. All right, so just like the battle for Helm's Deep, we're bringing all of our armies together. Armies of data or something. Okay, or something. So I'm going to import all the stuff that we've made. First thing, set up our storage objects, set up our camping plans, and then we're going to tell it where we're going to get our information. So we have our Forest Service URLs and reservation URLs from the elves. We're going to augment our reservation URLs data frame with that when we're going to be going away. And then we're going to be setting up all of our sources. So we've set up the storage, the MySQL store back up here. And you can use this CSV storage if you're not able to connect to the MySQL instance. It'll just store it all locally for you. And then we have, I think RIDB data live should work, but I'm going to comment it out just in case. So we're going to have RIDB data, Forest Service data, reservation data. So I'm going to set up those objects, and then I'm going to run data extract on just the RIDB data, so we'll go through this one at a time to kind of look. So then again, there's our data coming out of RIDB. So what we're going to do is we're going to, kind of a cool thing with object-oriented programming, we're going to make the one data list here. So we're going to make a list of all of our data objects. And we can extract all of the data in one line with this one weird trick, because they're all the same interface. We can just extract all the data, just like that. Here it goes. And we'll check our data size. There we go, very cool. Another one-liner, just to show you how awesome object-oriented programming is. Okay, so we've extracted all the data, and now we are ready to do some merging. So what I'm going to look at here is I'm looking at the columns for all of the different data frames we have here to kind of identify what are the consistent attributes across these different data sets that we might be able to merge on. So we have facility latitude, longitude, and name in all of these places. I know from the data set that you can't merge on facility name because there's like 5 different campgrounds called Lost Lake, and they're all in different places. So what I'm going to be doing is creating a little algorithm that calculates distance matrices and looks to see if the distance between the different campgrounds is below a certain threshold. It's going to say, okay, this is within like a margin of error that these are probably the same campsite. So we're going to create a merge index kind of based on that distance information. I didn't want to get too lost in that code because kind of the implementation details of how the distance matrix thing is happening is not super relevant to what we're talking about. So this is again, so we're going to have, of course, another object because that's what we're all about here is objects. So I have a distance merge data object, which is an implementation of our data interface here. So I'm going to send in that data list when I construct this object. And then I'm going to have the extract. So remember we have extract, put, and get is our consistent interface. And as part of the extract, I'm going to do this run merge routine. So when I run extract, it's going to iterate through the list. There's ways that I've ordered the list based on lists being subsets of one another. Try not to get too caught up in that. Basically, it's going to go pairwise and say, I'm going to look at a merge index that I'm getting out of a utility function here, so I'll go and just show that to you. Utilities. So here's where I'm computing the distance matrix here. And then I have a merge index that basically is going to, so the distance matrix, basically what that is I'm going to pass in one set of campgrounds and their lat longs, another set of campgrounds and their lat longs, and I'm going to get the distance, latitude, longitude distance between the two of them, okay? So that's all that's really doing here. And then based on saying, I'm going to pass in a limit to that function, let's say it's below, like, to be generous, like 1/10 of a mile. If they're within 1/10 of a mile, maybe we'll just consider them the same for the sake of this class. And then I'm going to generate an index based on the matches that were below those limits. So basically, if there's a match there, that means they're the same. And then in order to be able to do a database-style, pandas-style join on them, I'm creating an index based on that. And then the join will happen based on that new index. It's kind of the high-level view of what's going on here. So then again, that's kind of the guts of what's going on here in the extract method. So I'm going to bring in our data object. I'm going to say, here's distance merge data, initialized with a name, the list of data, and then again the MySQL store where we're going to put the information. And so I'm going to run through the extract, which again is basically merging all of that data together. So then I'm going to look here, and what I'm expecting to see is a combination of all of our data sets. So remember, from RIDB, we were getting these facility ID, facility description, email type fields. And then from our web scraping, we were getting these fields about reservations, restrooms, water availability. And then finally, from doing our query of the recreation.gov site, we're getting our sites available. So this data frame, we just do like .df. Hold on. So we have 15 representations here, 15 campsites. And looking at this made me realize that I glossed over a point earlier about how the RIDB data is being processed. So you'll notice we started out with, was it 18 campsites? One of them we dropped because it had no lat long data, which would have left us with 16. So why are there, was it, no, 18, 17, so there would be 17. And so there's only 15 here. So why did that happen? As it turns out, part of the cleaning for the RIDB data was a dedupe by distance. Let me see if I can pull up. If we kind of go back to lab 1, I can point that out. Okay. So if we come down to, I'll just do the whole thing actually. All right. So we had some duplicates in the data set is how that ended up happening. One of them is Eagle Creek Campground. So this was out of RIDB. It gave us 2 entries for the same place. Of course, the lat and longs, they render here based on how it's being drawn as having the same lat long, but it's not actually numerically the same. And then we had another campsite up here. This is another interesting one. So Lost Lake Resort and Campground, and then Lost Lake Campground, and you might be like, oh, cool, they're all the same thing. They're actually not. If you look at the latitude, and we'll see this on the map at the end, Lost Lake Campground is considerably farther away from where these other 2 guys are. But these 2 happen to be the same, which I'm able to dedupe out using that same distance matrix comparison. So just a note about how the data is being processed and kind of keeping in with that, checking in with the shape of the data. So we started with 18, 1 didn't have any information, 2 were duplicates, so now we're down to 15 campsites. So that's what's going on there. Okay. Okay. So now we've merged all of this information together. We have this one unified data frame that's going to give us all the information at our disposal about camping. Let me go back to the PowerPoint here. And so this is a abbreviated version of the other chart was getting too big. So we've just extended our little data family here. So we have another object. So all of these have the same interface is basically what I'm getting at here. Okay, so we are now on to the one pipeline. So this is the lab where hopefully all of this will be worth the effort. Let's go through. I mean, hopefully it's been worth it like the other labs too, but you know, this is kind of the punchline. Okay, so here we are, the one pipeline. I want to thank everyone who has laughed at my Lord of the Rings puns throughout this tutorial. It makes me feel good. Thanks. I find technical content can get really boring and dry if there's not something else going on. So I think I did a talk about the Hitchhiker's Guide to JavaScript or something at one point too. So good to know that still kind of works. So I'm sure you will be totally unsurprised to see that I am creating yet another object that is also based on the data class. And this is why it is the one data pipeline to rule them all, because ultimately, it's just another data source. So you've built this data pipeline, which you can then use to input into something else and just have a data source. So again, I have my extract, put, get methods. What I'm passing in here is I have the data list. So that'll be all of our data sources. The merge type is going to tell us what type of merge we're going to run on it. And then our store, which is, again, our storage type object here. And you can see that I'm passing off, so in extract, I'm saying, okay, whatever this merge thing is, I'm going to send off our data list and our storage to that, and that's going to handle the storage for us. The storage objects are going to handle that for us. So really, this is just kind of a wrapper to be like, okay, extract the data. So we're going to bring all of our armies of data, storage, scraper objects, etc. Going to set up our camping plans once again. And then we're going to go through this. Should look very similar to what we just went through. Okay, so then we're ready to create our pipeline. So we have our list of RIDB data and Forest Service data and reservation data in the list. Then we have the distance merge data object, which is what we just went through, that's going to do all of the merging for us. And then we're handing in this storage object. So we'll create the pipeline. We'll run through extract. All right, so let's look and see what we've got here. All right, so we still have our reservations, restroom, water, sites available, all the other members of the band. Let me do and then we'll just check. Okay, so we have our 15 sites as expected. And now we're going to do some visualization on this data that we just got. So I'm going to set up bokeh, and then I'm going to say, so since people seem to be really into having restrooms and water where they camp, I thought that might be a good thing to, just take a look at. So I'm going to take a subset of the data frame from the pipeline and say that if there's no sites available, just forget about them. I don't want to look at those. So I've now created this sites availability object. So you can kind of get a preview of what that's going to look like here. So you can see we have, for some things where we didn't have any kind of either a website or recreation.gov entry, we don't have any information for those. It's probably not a coincidence that things that don't have the website data also don't have the recgov data, since those are managed by the same entity. But just to give you an idea of what we're looking at, and then I'm just going to put up a little plot. All right, so this is our plot. Could probably pass in a name so it's a little more obvious, of sites that are available that have restrooms and toilets. Toilets of some variety anyway. So then you mouse over these and you're like, okay, there's 2 sites at Camp Creek, 2 sites at Lost Lake Resort, and 2 is like the magic number. Oh, there's no sites available. So that would be a thing to filter out, is not only if there's NANs, but if none of the sites are available there. Yeah. So that's pretty much all I had. Just kind of go through the process of getting all this information, organizing it, and extracting it. And then if you'd like, you now have this little data frame of information on campsites. If you'd like to visualize some different stuff, we can, let's see what this says. Yeah. So I guess I'll take any questions. I could play around with stuff up here, but I don't want to waste your time if you're not interested in that. So are there any questions?
So in terms of use, what are the places you look on a website for terms of use?
Good question. So for terms of use, I would typically look at some of them, if you they have information about their data and they'll just tell you. A lot of times if you look at kind of a legal page or an about page, you might find some information. if I can't find information, like most of this stuff I'm just doing for my own fun. It's not like, this is not for anything work-related, so I will usually, if I can't find any kind of information, I'm just doing it for fun, I don't really worry about it. Yep.
So we'd say that having some experience with looking for terms of use where they don't exist.
Mhm.
Usually if it's not listed,
Mhm.
then they can't really,
Okay,
it's not on the website.
good to know.
So, because, and particularly, there's also even been some argument that if you have to click somewhere specific to get to it that's outside of where you might interact with the data, then it also might not be applicable if you don't know it.
Excellent, thank you. So if you can't find information, you have implicit permission, apparently. So, yeah, cool. Any other questions? Yeah?
Have you had, this site is live.
Yes.
And have you had problems with the sites changing structure and your code breaking, or, I mean?
I did have a problem, so fortunately nobody is touching those Forest Service web pages. Like, it's kind of a good thing. Like, this technology is like super far behind, so I'm kind of like, well, it works for me. I did have a situation, if I pull up the code for, where are we here? Web files. So in the reservations, this form name changed. So I did have a problem with that particular piece breaking, but fortunately the stuff that I'm using for the website, which I don't know if that will even come up with the, oh, yes, okay. So that I can show you. So Camp Near Portland. And this is kind of a more fancy version of what we were just looking at that has all of the information here, and then you can tell it, like, because I do get that availability information, so, right, we're looking at what's available, so I have availability for the weekend, so you can then look at what's available for the coming weekend and get information on it. So this is kind of a perhaps more sophisticated visualization of the data that we just pulled apart to give you an idea of what you can do with that sort of information. Yeah, so. Are there any other questions? No? Okay. Well, that's really all I had. I'm happy to talk to you if anybody has questions or just wants to talk about some of the methods that we went over. I'll be here. So thanks for coming. I think I had final slide. Thank you. Yes. Yes. Cheers. Okay.